In this problem, we are given the following situation. We've got two charged plates, a positive and a negative. They're large flat plates, and they're moving to the left with a velocity v. So I might as well put a coordinate system on here. And so they're moving in the positive y direction with a velocity v. We are asked to find the momentum stored in the fields for these two moving planes. And so we need to know what the electric and magnetic fields look like between these two. Luckily for us, we already kind of know. We know that the electric field, right, is going to point from positive to negative down. And it's a parallel plate capacitor, so it's going to be constant in between and zero outside. We've done this problem before. Similarly, for the magnetic field, we know that if the current is going that way, let's see, right-hand rule. For the upper plate, the current is going that way, and so fingers curl around. So the magnetic field will point in the minus x hat direction. And so we're going to be able to write that the B field is going to be, let's see, this is going to be K, mu naught times K, so it's mu naught, K will be sigma V, in the minus x direction, so minus x hat, in between, and 0 elsewhere. And we know that the electric field, E, is going to be sigma over epsilon naught in the minus z hat direction in between, and 0 elsewhere. So now we want to find the momentum stored in the fields. To do that, we can use the momentum density, G. The momentum density is defined as epsilon naught times E cross B. And so we can just write this down, right? And so G is going to be epsilon naught. That'll cancel that. I still have the mu naught, so this will give me mu naught sigma squared V. Then E cross B. Let's just do right-hand rule. E, B, the momentum is unsurprisingly in the positive y direction, plus y hat. That's that. Okay, so that's the momentum density. To find the momentum, we simply have to integrate. And so P total is going to be the volume integral d3x of the momentum density over some volume. Well, that's going to be this distance, which we might as well call delta z, times the area, which we might as well call A. That's going to be the volume. The volume is A times delta z. And so that gives us just algebra, right? Just plugging stuff in from above. P total is going to be then mu naught sigma squared V A delta Z in the positive y hat direction. So that's the total momentum that will be stored in the fields.